Hello, pre-calculus students and seekers of truth. Let us continue our study of sinusoids with one more example here, where this time we have all horizontal transformations, and whatever's in the parentheses actually gets done last when it comes to horizontal transformations, because everything happens a little bit backwards here. So the first thing that we have to note here is this is modifying the input. So this is actually a horizontal shrink, right? It is a horizontal shrink of 1/3. All right. And then after that, we are going to shift horizontally 4 units to the right. Okay. And to be clear, we're going to do the horizontal shrink first, and then we're going to shift 4 to the right later. Okay. So let's look at the sine function once again. It's going to go up, right, and then it's going to go down, and then it's going to go up. Over here, it's going to go down, it's going to go up, and then it's going to go down. And there are no vertical stretches or vertical shifts, so we know that the max will occur at +1 and the min will occur at -1. And these points right here, the x values of the maximum, this x-intercept, the x value of the minimum, and the second x-intercept, remember these used to be pi/2, pi, 3 pi over 2, and 2 pi. So again, I like to draw a little baby sine graph here. Right, so this point here occurs at pi/, that was maybe too small of a graph. Let's try that one more time here. So let's see. You got, the sine graph used to be up here. It used to be like, this is at pi/2, and then pi, and then 3 pi/2, right? And eventually, you'll get so sharp at all of this stuff that you don't need to repeat this graph, but I'm drawing it here so that you can see it. The first minimum occurs is actually 3 pi/2, 3 pi/2, okay? So all of those points then, when we apply the horizontal shrink, get multiplied by 1/3. So this is again pi/6, pi/3, and then here 3 pi/2 times 1/3 is 3 pi/6, otherwise known as pi/2. And then right here, the second point here, this is going to be 2 pi/3. Okay. So we've taken care of the horizontal shrink. Now let's talk about the shift. Okay, so we're going to do the shift after we perform the shrink. Okay, so our final answer here, we're going to transfer that to this graph. So everything here gets shifted over exactly 4 units to the right. So instead of starting out at 0, 0, it's going to start out over here at 4, 0. And then we're going to go up, and then down, and then up, and then down again. And then over here, it's going to be kind of the same thing. And I'm not drawing this a great job. I'm not doing a great job of drawing this, but hopefully you get the idea that instead of starting out at 0, 0, like we have over here, everything's been shifted over 4 units. So this point right here, the first maximum, it's going to be 4 plus pi/6. Okay, whatever that number is exactly, we don't have to worry, whatever the decimal approximation is, we don't have to worry about too much right now. This number here is going to be 4. This is where the first the x-intercept occurs. 4 plus pi/3. And then the same thing with this first minimum point, and then the second x-intercept, or the third x-intercept here. And then we can answer some questions here. Well, what is the amplitude? Remember, that's max minus min divided by 2. There are no vertical shifts, or there are no vertical stretches or shrink, so the amplitude remains 1. The period has changed, right? The period has changed because instead of repeating every 2 pi units, we've shrunken it by 1/3 here, so the period is going to be 2 pi/3. The phase shift is 4 to the right. Or we could say it's positive 4, but I just prefer to say it in terms of this 4 right. Otherwise, we could say positive 4. And then the horizontal shift is just what you get when you distribute this. So the horizontal shift is 3 times negative 4. Or we could say that it is 12 right, or it's positive 12. Moving to the right and having a positive number is the same thing. Remember, all the horizontal stuff is backwards from what our intuition is. All right, so that concludes this video and this part of the lesson on graphing sinusoids. And again, always use your calculator to check there's nothing wrong with that, but always exercise your mind by making yourself think through these processes as much and as often as possible. Thank you for watching. Ask for help if you have questions, and have a wonderful